Yesterday we started to find. So the first part of the course was dedicated to blockchain technology, and the second part of the course is roughly dedicated to different applications and case studies. So we started with it yesterday when we considered digital identity management and the role blockchain plays in this context, and we continue today and also for the rest of the course. So this lecture is about some blockchain applications, some case studies, definitely not an exhaustive coverage. But specifically in this lecture we are focusing on supply chain management. So what is supply chain? It's a network of individual organizations involved in creating a product and delivering it to the consumers. So in this simple example, there is supplier of raw material, there is manufacturer, and there is wholesaler who would be delivering goods and products to, say, pharmacies, hospitals, and eventually they would be used by the end user, by the customer or consumer. So in realistic supply chains, there are many more elements or participants in the chain. So a typical scale of, well, of course, depends. There are some small supply chains, but say in a typical manufacturing, say pharmaceutical, say medical products, there could be up to 100 different participants, right? So that would be like typical scale of a supply chain. So some examples. Energy distribution, right? So here I would probably use actually the example from my home country, Norway, because in Norway there is like strict separation between roles in energy distribution. There is a producer of energy, there is distributor of energy, there is provider of the infrastructure, and those three are all different organizations, right? So, for example, it's possible for an end customer to choose different producer of energy on a daily basis. So you have just an app on your cell phone, and you can say, okay, today I'll be buying energy from that producer, but still would be using the same infrastructure provider. Okay, so various sources of energy generation. So energy may come from a battery. Energy may come from like global producer of energy. Energy may come from micro producer. So people are installing micro turbines in their homes, right? And in Norway there are a lot of rivers and in a lot of mountains. So most of the energy produced is due to hydro. Right, so someone living next to a river would be installing microturbine in the river, and this way would be producing small amounts of energy and would be injecting this energy into the power grid, right? But on a global scale, it's also possible to buy from other countries. So there is a lot of energy trade between the countries in Europe as well. So this gives you the idea of the scale of supply chain in the case of energy distribution. Okay, other examples. Logistics, how to track, say, warehouses, billing, invoices, food chain supply, agricultural supply chain, which is also related to food chain, manufacturing, and there are many more. We are going to see many more in the course of this lecture. So why supply chain? because because the roles in a supply chain are inherently distributed, right? There is no one entity or one manufacturer which can be responsible for all. Like farmers growing cattle and producing dairy products, or sort of gaining milk from the cows, would not be the same entity which is, say, producing dairy products, which would not be the same entity as the shop, right? Like in the early days of the civilization, maybe like the same person could do all those jobs. But today we have very strict separation of responsibilities. So the role of each entity is different. And there is a need to regulate the relations between those entities, right? So due to regulating the relations between the entities in the supply chain, we can get higher productivity, better efficiency, and accordingly better profits. So we can also provide more, like we can plan better in terms of how to deliver the products, right? Because the times when the shop is open do not necessarily need to be the times when the manufacturer is available. And this way, of course, it's much easier to reach to customers at global scale. So the problem of supply chain management, or I'll use the abbreviation of SCM in this lecture, is to manage all the cycles and all the interactions between all the roles and all the players, all the entities in a supply chain. So, and indeed there are many decisions to be taken, right? So, so how do you select how you as, say, one entity responsible for one role in the chain, how do you select the supplier of the raw material, and how do you select to whom you deliver your products, right? Is there some centralized planning for the entire chain, or does each element in the chain autonomously decide whom to use? Okay, then even if I know who my suppliers are, I still need to manage the relations with them, right? Like procure the goods, keep track of everything, and that means logistics. So I need a warehouse for the goods. I need to manage the space. I need to manage the time. Of course, I need to keep orders, billing. I need to take care of the transportation, or at least make sure that the transportation is functional. And on the other hand, I need to plan the production of the goods. So even planning, and the algorithms for scheduling when to order, when would it be optimal to order which good, and how to use the available resources. And say at the factory where you have many machines, how do you use those machines in an optimal fashion? All those are quite difficult questions. And you also need to forecast the demand and organize the sales and plan the distributions, right? So there are so many different activities all involved in supply chain management. Of course, on the other hand, you get many technical challenges. So to what extent the construction of the supply chain need to be totally bottom-up, and to what extent it can be top-down. And it's also interesting that like different countries, different cultures, different domains, application domains, would use completely different techniques to this end. So the demand forecasting, I mean, like how to make it accurate, because it would never be 100% accurate. Repudiation. How do we record the claims? Repudiation means that a person can essentially say something which would be, or even send a message. The interaction between two chains in a supply chain, two elements in a supply chain would need to be recorded, right? And later analyzed, because otherwise it could be misinterpreted. And someone may claim that, no, I have not said that. I meant something else. That's very common in such interactions. So there is also a need to resolve disputes, of course. And how do you build the trust? How do you build a reputation? How do you ensure the transparency of the information? How do you monitor all the goods being delivered? How do you track? How do you verify the compliance with all the agreements? How do you make sure that the information, that the goods are secure? How do you make sure that the goods are delivered, say, in a good condition? How do you make sure that the information in the agreement between two parties is not leaked? It's not available to the competitors. And of course, like the process of bidding and management, and managing also the cost for end users and determining the price of the end products. All those are technical challenges in supply chain management. Okay, so what role can blockchain use in this, in supply chain management? So supply chain in blockchain, I mean, usually such applications are not built with the help of just one technology. You need a combination of different technologies. So you would be using smart contracts with blockchain, with the IoT, and sometimes you would also use AI. So what role would each technology play in this case? Well, IoT is absolutely mandatory. The user, because there is a need to use sensors to monitor so many elements in the cycle. So to give you an example, like goods in a ship would, so they've had a joint project with a major global operator of maritime logistics. So in a ship, when you send the goods, you would be monitoring humidity, temperature. You would be sometimes would be monitoring it, like a presence of some of maybe some elements in the air. Well, not only air pollution, but also, say, if the product if the product maybe is spoiled, there is a way to detect that depending on the product. You would be monitoring the level of vibration in the ship. And all of this you would be doing by using sensors, right? So all of this needs to be automatic, and the sensor would send information to the to some data center, right? And the data center would store this information and process and analyze this information. And of course, this needs to be done on each and every step. Okay, so there are many challenges here, right? How to make sure that the information is correct? How do you make sure that the sensor is not malfunctioning? How do you make sure that the sensor is not being tampered with deliberately? So there is technology for counter, like for preventing tampering with the sensors. So that's the role of IoT, and of course the use of tags. Essentially, it's common in the supply chain to tag each and every product, and it's like the RFID technology, so it would be some unique ID assigned to each and every product. So for example, there are applications where, like on your cell phone, where you say you go shopping, and each product would have the tag and would be also sending information using IoT. So the app on your cell phone will be able to show them the manufacturer of the product, when it was produced, maybe trace it back to individual components. I'll give more examples in this lecture. Okay, so that's about IoT. AI and ML, of course, help you with the forecasting the future. That's one of the probably main reasons to use AI in this context. So smart contracts and blockchain help with the elimination of intermediaries and also improve transparency. So so if the sensor is not tampered with, then the information is reliable, then we can make sure that the information is recorded on blockchain, and that increases transparency and verifiability of the information. So I can tell you about some projects like in the European and also North American context. So they in North America, in one project, they try to allow tracking of dairy projects. So for each dairy project, you can track it to the cow which produced the milk, and not only this, you can track it to the producer of the food that the cow was consuming during the period when the cow was producing the milk. So even some, like, you can get images of the cow, so and you can do it like for each dairy product, so that there was full traceability, and they try to achieve it for blockchain. Similarly, for coffee, say you order coffee, you can track it to the plantation where the coffee beans were produced. And again, using blockchain. So use of blockchain in that context can enhance the security and also facilitate automation through the use of smart contracts. And also help with, through transparency, we can also prevent counterfeit with high probability. So this is the general idea. Now I'm going to mention a few specific case studies of the technology. The case studies are mostly taken from the Indian context. So the first case study is a property chain in India, where the chain is designed, so the technology of property chain has been designed and developed by Center of Excellence in Blockchain Technology, National Informatics Center, that's financed by the government of India. And the idea is to record and store property and land records in secure manner using the blockchain technology, but not only to register the land records, also to register all various transactions involving land ownership. between the stakeholders and linking those transactions in a sequential order. So, so the different entities from which information would be flowing in and stored on the chain would be of course individual citizens and the registry and the government, but it would also include, say, court orders, banks, and loans, and so on. So there is obviously an ecosystem surrounding real estate, and transactions within each transaction within the ecosystem would be registered on property chain. So there is also, of course, question of distribution, right? So property transaction can take place in multiple locations, and of course the idea is that the blockchain helps with tamper-proofing. In the province of Karnataka, there are several applications such as Bhumi, e-Asti, e-Svato. So in those applications are integrated with property chain for recording the transactions and state of the property. So how is it implemented? What's the conceptual idea behind the architecture? Well, I wish I could have like more specific details, but so I can only speak at a high level. But at a high level, it looks like you can see in this depiction. So there is property chain, which is the blockchain. There is off-chain database, both are used, and services are built on top of that. So the services would include document storage, document retrieval, user registration, authentication, and so on. And then there is an API towards individual users, and of course all users need to be authenticated and authorized in order to use it. So some of the users would be financial institutions, and some of the users would be revenue department, and so on. And of course, the whole architecture makes heavy use of digital signatures and dedicated or sort of also using network protection technologies. Next case study I'm going to mention is logistic chain, and not just any logistic chain. It's for drugs. So in drug logistic chain is the drug supply chain established using blockchain technology to record the transactions. So in this chain you'll have the producer, pharmaceutical producer, transporter, warehouse, quality lab, hospital, and patient. And obviously there are also pharmacies, even though not depicted here. So again, used by the province of, by the state of Karnataka. So it's integrated with blockchain, and the purpose of blockchain is to record the transactions related to movement of drugs from the manufacturer to supplier to warehouse, and that also smart contracts are used in order to provide the checks and balances in each state and ensure compliance. So obviously there are many issues many issues that such an application requires protection from, and the auditability of blockchain helps with monitoring those issues over time. So for example, a patient can check the details of the manufacturer, expiry details of the medicine, and the quality of the medicine before consumption. And there's also support for recall. Sometimes if they find a problem with the medicine, they need to recall the medicine, the product, right? And the question is how to perform a recall, how to reach to all the customers who already purchased the product. So it's not like with cars, because all car owners are registered, but not if you purchase. If you purchase a medicine, you are usually not registered. If you go to the pharmacy and just purchase a medicine. So for the use of blockchain now, all this information can be reliably stored on the chain, or more precisely with the help of the chain. And then, and that facilitates the execution of recalls. In those cases, you need them. I can talk about another case study, not from the Indian context. It's mostly like in Switzerland, but also other parts in Europe. So development of medicine. So it's pharmaceutical, but it's a different application. It's development of medicine. So development of medicine requires a lot of research, a lot of trial and error methods, right? So you take some a molecular constitution as the basis, and you try to change it, and you try to evaluate the effect in a clinical trial, and then you record the results, right? And usually it's a large-scale collective method, right? Because like different labs would be trying different modifications to the molecular structure. And the thing is how to make sure that the information about the clinical trial is correct. How to make sure that because obviously there are a lot of financial incentive to fake the results of the trial. So how to make to ensure non-repudiation, meaning that someone would not be able to lie about the results of the trial, but also how to ensure that the information, say, about particular attempt to change the molecular structure would be available, widely available to other labs and shared. So that's the context of the application, and then the idea was to record such trials at large scale and share them through blockchain. Of course, the information about molecules itself can be too large to put on blockchain, but the blockchain can be used to secure this information, even if it's stored in an offline database. So in the last lecture on blockchain-based or blockchain-assisted storage, I will discuss such hybrid storage systems. But this is yet another case when there is a use of blockchain, even though it's not a classical supply chain, but you can view it as such. Okay, coming back to the Indian context, there is another interesting application called the blood bank application. And the objective is to ensure that the patient gets safe blood. So safe blood means, of course, quality of blood, means the right type of blood, means that the blood is not contaminated, and of course doesn't contain any disease or anything. So donor history can be known, even though it's interesting because in many cases you are not allowed to know personal information about the donor, right? You're not allowed to know the name of the donor, for example, but you should still be able to know some of the medical history. So there is an interesting trade-off here between privacy and quality of insurance. Yeah, There is also expiry of the blood supply, so expiration date can also be verified. And that there is also a question of availability of blood at the different places. So in this use case, the idea is to record transactions right from donor registration to hospital and other important properties of blood like group testing, temperature maintained, and store all this information on chain, or again, maybe in a hybrid system, but with the help of chain. So, I mean, this is obviously life-critical application, which is presumably more important than other like fun applications such as tracking dairy products. So in this lecture, we have used the information provided by the Government of India, specifically the Center of Excellence in Blockchain Technology, about those use cases. And that's the end of the lecture. I would like to thank you.